Dear conference participants, the topic of our presentation is Modified Three-Stage Model for Forecasting the Demand for Energy Resources at Various Hierarchy Levels of the Economy. Speaker: Olena Maliarenko, Candidate of Technical Sciences, Head of the Department of the Institute of General Energy of the National Academy of Sciences of Ukraine. Slide 2 presents the relevance of the study, which is to create a mathematical model and tools for forecasting the demand for energy resources to determine the amount of emissions of harmful substances into the atmosphere from the combustion of fossil fuels. Slide 3 shows the structure of the mathematical model. Hierarchical levels of the economy were studied. Level 1, the macro level, is the country. This level is an indicator of gross value added of the country. Level 2, meso-level 1, types of economic activity in the country. This level is an indicator of energy intensity of gross value added. Level 3, meso-level 2, the economy of the region. Indicators of this level are the gross value added of economic activity in the region and energy intensity of economic activity in the region. Slide 4 shows the structure of the mathematical model. A feature of this model is the possibility of transition from energy consumption in the country to energy consumption by type of economic activity of the country and to regional levels and vice versa. The proposed model is flexible and convenient in determining energy consumption forecasts. When modeling energy consumption by type of energy resource, the scenario method is used. It considers two scenarios of economic development, basic and promising. The existing structure for the base year is determined as a percentage of energy consumption of a particular sector of the economy or group of economic activities, to the energy consumption of the country, as well as the level of energy efficiency of the base year. The perspective structure according to the tendencies of change of these percentages for the retrospective period or according to world tendencies taking into account the technological potential of energy saving. Slide 5 presents the novelty of the presented model. The novelty of the presented model is to determine the agreed forecast levels of energy consumption by sectors of the economy and by region, taking into account the economic structure, and also coordination of the received forecasts between consumption, country as a whole, total by type of economic activity, total by regions. Slide 6 presents forecasted demand for electricity for scenario-based economic structure and technology-based energy-saving capacity identified at various hierarchical levels of the economy under pessimistic, structure of 2017, and conservative, structural changes happen, scenarios. The results of calculating the demand for electricity in different economic structures for each level are presented. Prior to reconciliation, we have a discrepancy of up to 22% at the end of the period. Slide 7 presents forecasted demand for thermal energy for scenario-based economic structure and technology-based energy-saving capacity identified at various hierarchical levels of the economy under pessimistic, structure of 2017, and conservative, structural changes happen, scenarios. The reliability of the obtained results of projected heat consumption in 2020 compared to 2017 was also assessed. The error is not more than 9%. Slide 8 shows results of assessing probable coal savings if the optimistic scenario takes place as compared with the pessimistic scenario, development of Ukrainian economy with the structure of 2017. As calculations show, the forecasted reduction in coal consumption may amount to 7.8 million tons by 2040 due to structural and technological changes, 2.272 million tons and 5.544 million tons. Appropriately, The reduction in coal consumption will reduce emissions of pollutants into the atmosphere, 1,000 tons, nitrogen oxides 19.7, sulfur oxides 295.1, carbon monoxide 393.4, particulate matter 104.3, carbon dioxide 5271.8. Slide 9 presents the main conclusions. The presented three-stage model allows solving of two tasks. Forecasting energy consumption at the top level, for the country level, and forecasting of energy consumption at two lower levels, which may be changed depending on the task. Types of economic activity or regions. The proposed model allows forecasting of changes in energy consumption due to structural and technological changes in the country's economy, which makes it possible to determine forecasted changes in emissions of pollutants into the atmosphere related to combustion of fossil fuels, including coal.